All right. Hello, everybody. So, I'm going to talk about Autodesk Inventor here. I love this software. I use it every day in my professional life. I have for, probably 12 years. AutoCAD before that. I've been using that since I was in middle school because I'm a nerd. Um, but as an engineer, you got to draw stuff. So, there's really like two modes of thought. Some people say that we need to be um, more engineers and less draftsmen, but then the other people say we need to be more draftsmen, less engineers. Then the tools are built nowadays that to have both engineering and just CAD design, or let's say CAD design, but geometric design capabilities built in all in one. And so there's a lot of engineering tools, and that's CAE. That's something you don't hear much anymore. I don't know if it's a deprecated term or people just don't use it. It's hard to say CAE, but computer aided engineering. And so Inventor has uh, both engineering and geometric design stuff built into it. Now, as you're probably well aware, Inventor is known as a parametric 3D modeling design package, which means your geometry is driven by parameters, um, but you also have other metadata that goes along with the model. And the point there is it captures everything that you need to actually the um, build the parts, build the assemblies, put everything together with minimal documentation. Now, we still live in a society where most industry, I think I can say that, obviously I've got a very limited experience. I'm only one person, but most industry still requires paper prints, especially your small job shops, specialized, low volume, high mix kind of thing where you don't do the same thing twice, and you might not do much of it, right? So you might build onesies, twosies, you might reuse a print, never have to draw that thing again, or you might have new stuff coming in all the time that you need a quick design for. So where Inventor and 3D modeling really shines is you can build the thing in the computer in its entirety before you build it in real life. So that's cheap. You can iterate really, really fast. But then also you can reuse data easier in the future by capturing metadata. So you capture more information at design time, and you don't worry so much about all that stuff when it comes time to annotate your drawings or use that design deliverable. So let's get into it. I'm just going to draw a quick part and show you how fast and easy it is to draw, like, oh, I don't know, something. So I'm not sure why I'm not drawing a new part now. There we go. This is actually the first part that I've drawn with this particular installation. I just installed this on this computer yesterday, so I guess it takes a little while to get set up. So we're going to run through all of this in its entirety. We're going to talk about 3D modeling and sheet metal. So sheet metal is another really important feature of Inventor. And then I'm also going to show you how to use everything in a connected workplace kind of an environment. So Autodesk provides what's called Autodesk Vault, which is PDM, Product Data Management. And it's almost a necessity to use that when you're working in a multi-user environment with 3D modeling stuff. And it doesn't matter if it's Autodesk or SolidWorks or Pro-E, you've got to have some sort of product data. Excuse me. You got to have some sort of product data management. So, I mean, that even goes for 2D files as well. You got to have some way to control access to who has what and what information the files have in them and so forth. Revision control, ECOs, which is engineering change orders. So I'm going to look at this from a realistic perspective, but I'm going to use fun examples. So hopefully I'm going to pull some stuff from Factorio and Space Engineers, and then we're going to build it in real life. I'm going to take you through like all this stuff. So we're going to start at Inventor. I'm going to give you a full breakdown of Inventor, and then I'm going to take that to real life workbench. We're going to weld up some armor blocks, using prints and dimensions, and go through what you need to build stuff. And then Factorio, I think we built an inserter. So and then all the electronics that goes along with it. Now, what we build from scratch and what we build according to the game, some of the concepts in the game are not very realistic in terms of building um, stuff by hand, like out in the middle of the woods. You know, you can only do so much in your pocket. So building a circuit board, basic electronic component. And I might be thinking about Angels mods because it's been so long since I played Factorio too. But I did love the game. I've got a lot of time on Space Engineers. I got a lot of time on Factorio. And I think it's time to bring it to real life. So let's get started. I'm just going to draw. Let's start drawing a armor block in its most simplest form in Inventor. And so I'm just going to run through the steps real quick. And, you know, again, this is a high-speed flyby. I'm going to offer this in a full course as well on another platform. But so you can actually see this step by step going through it all. But I'm just going to kind of give you some highlights here. There's all kinds of, you know, learn the basics in 30 minutes or whatever. But so I'm not going to spend a whole lot of time on that stuff. But the course is going to go into in-depth, and it's going to be basics, but also advanced, using it in a corporate kind of environment or an actual, you know, design idea to an out the door ship to customer. And I'm going to show database integrations with ERP. I'm going to show the whole kit and caboodle. And I'm going to set this place up as like a production environment. So all you accidental CAD administrators out there have a resource to go to. So I'm kind of trying to watch my time here. All this stuff is new to me, and I can only make 15-minute videos on YouTube, but we'll get there. So let's draw an armor block. Cool thing about Inventor and a lot of 3D modeling packages is you can just type in the units that you want to use right here in these dynamic dimensions. So I've got cursor input. If you see there on the screen, this is called rubber banding. So this box is stretching in all the different directions. This concept here of seeing the geometry move with my cursor, that's called rubber banding. And so the dimension input there, if I type on the keyboard, you see there's a 1. Now, if I put an M after it, that's 1 meter. So Inventor is smart enough to figure that out. It's pretty cool. So I've got my drawing unit set to inches because I'm in the good old US of A. And I like inches. A lot of the small shops I work with around here use inches. Now, if you're a international supplier, then metric system is probably your thing. But I'm going to use inches and let the software do the conversion where needed. Okay, so what I've done there is I put 1 dimension on that square, and this is going to be the cross section of the armor block. So that's 1 meter that way. I think armor blocks are like 1 meter in Space Engineers. That's what we're going to call them anyway. So now I'm just going to add another dimension quickly to this side. Oops, that's what happens if you put in a stupid thing. Okay, so there's 1 meter square. I'm going to finish that sketch, and then I'm going to extrude that. Okay, hit my extrude button and go both ways. 1 meter. So now I have a 1 meter by 1 meter cube. Okay, so there's an armor block. Now we're going to make a drawing of it. So I just click my new button up there. That pops up this create new file, standard drawing, and I'm going to click through all this quick. But since I've got this part open in memory, if I hit place base view, it's just telling me, do I want to save it? Yeah, sure, I'll save it. I'm going to put this in YouTube content for now because I don't know what else to call it. And we'll call this light armor block simple. Okay, so there's 1 view, 2 views, 3 views. Okay, so I like to go ahead and get my views in there. This sheet, let's edit this bad boy. Sorry, this sheet. This is the drawing itself. Right click on sheet, edit sheet. And instead of a D size, I'm going to make this a B size because I can print that here. Click OK. So now that you see that changes the aspect ratio on the sheet. Now that's an actual B size sheet, which is 11 by 17. I'm going to double click on a view here. I'm going to change it to 1 inch equals 1 inch. So that's full scale. Okay, so that's big. I want it to be 1/10 scale, maybe. Will that fit on there? Let's see if we can do that mental math. I think it needs to be maybe 1/20th scale. So 1 inch equals 20 inches. And let's just call it 2 feet. So 1 inch equals 24 inches. So 1 inch on my paper equals 24 inches in real life. That's what that means. And that's a good size. And then this one here, the base default kind of behavior in Inventor is to not scale the isometric. Okay, so now here's a drawing. And you can see that we're doing this. I'm just going to quickly place some dimensions here. And again, since I'm drawing in, and I'm going to deselect this, this is why this box key is coming up. I don't want to edit that dimension. Okay, so there you go. Now I'm actually going to delete this view, and I'm going to put this dimension here. And then I'm going to just go into this view label here. And I'm about out of time. But real quick, caps lock, front elevation. Turn that view label on, change the label, going to bring it up here. I like to underline and italicize my view label names, so I'm going to do that. And then this one here, same kind of thing, italicize, underline. This is going to be right elevation. Click OK. And there you go. So now some of the terms that I use, and I'm going to explain to you why I use these terms. This is kind of a mechanical design and architectural kind of design all at once, because we're building a space station structure. So there's going to be a lot of mechanics to it, but there's also going to be a lot of like architecture. So elevation is something that you would see in architectural drawings, and elevation and orientation or plan, you see this in a lot of process design stuff as well, pressure vessels and process equipment. So here you go. So that's the simplest drawing. Now I'm going to save this. So you've seen now I created a part and a drawing in, less than 15 minutes. I don't know how long I've been talking, but it hasn't been 15 minutes yet. So there you go. And so next time we're going to go into why this is only marginally useful, this sucks, and we've only just begun talking about Autodesk Inventor and its capabilities and how you use it in real life. So until next time, bye.